Fine, you have seen the code for cuboid class. Okay, let's see that again. And yeah, and then one more thing, I think one important thing which we were doing was we decided that we would keep the class name as cuboid only, right? And then we found that we will have to use some prefix to distinguish between the two. Okay, so yeah, so one thing what we introduced was package. Okay, we have introduced package. Okay. So we decided that we should have package, right? We should use some prefix, and our class names should now change. Okay. We earlier had class called rectangle, right? Which now changes to shapes.rectangle. We had the class called cuboid, and this has changed to the one which uses inheritance. For that, yes, we said, oh, let it have a prefix like this, right? Shapes.inheritance. And we created yet another cuboid, and we have called it as okay, fine. One thing we could do is change this again, and we had like to change it to, let's call it as shapes. Okay. So, since this is a more appropriate cuboid, and this we would like to make it as part of the same package as rectangle. Okay, fine. Cuboid, this was just showing inheritance. Okay, the earlier cuboid. Also, we decided we had this class called test rectangle, and that should be called as test.test rectangle. Similarly, we had the class called test cuboid, and that should become test.test. Okay, fine. So these are the things which we decided about the names for the class. And so classes will be like this now. Okay. Fine. Okay, so to achieve this, what was done? Okay, in each of those class definition, one thing, other thing also we realized was, in order to these classes to be usable, okay, especially the first three, okay, they should be made public. Okay, and public class requires that we have the class uh, with the file name and class name should match. Okay, that is a requirement. Okay, so so the next step which we had taken was rectangle class in rectangle.java. It was anyway the case for the first thing. Yeah, we had the same file name. Only one thing which we had to do is, for the one with composition, what we did was we created a folder for composition and stored the Java file over there. So we have two separate Java files with the same name, but we had to use a different folder. Okay. One thing what we had found was that when we use compilation, right? How do we compile? Use Java C minus D. We give a destination. In our case, we said, okay, dot dot backslash bin over here. Okay. And we compile, for example, we said, oh, let's compile rectangle.java. Okay. So when we did this Java C minus D and we specified the bin folder, right, saying oh, the class file should be created over here. When it was compiling a class file without the packet declaration, okay, the class file was found in the bin folder, in that destination folder. But when it compiled the class with the packet declaration of shapes, okay, we said packet shapes, then automatically what we found was the rectangle class, okay, the class file for rectangle was within the bin folder. So in bin folder, which is the destination, it has created a folder called shapes and then put rectangle.class. Okay. So we find that compiler is organizing the classes into folders according to the packet declaration. Right? And this is a good way of organizing, because see, other thing is, when we are looking for, what are we looking for? We are looking for a class called, we are looking for a class called shapes.rectangle, right? When we look for shapes.rectangle, fine. So anyone is looking for shapes.rectangle in bin, okay, in bin folder. Okay. What is expected is a folder called shapes. Fine. Containing the okay. So if I'm saying, oh, I will load the class from bin, so that's the appropriate place for loading the class shapes.rectangle. If you are in shape folder and say, oh, let me load shapes.rectangle, fine. So in that case, it would fail to load the class. Okay. So rectangle, fine, appearing shapes.rectangle appears in the folder shapes under the fine, so it would appear under the shapes folder because the package is shapes. Okay, so that is something which is necessary for loading the class. Right? So place is bin and not shapes, where shapes.rectangle is available. Okay, rectangle class is in shapes folder, but that's not the place where you load the class from. You load the class from bin, and class name is shapes.rectangle. Okay. Sorry. Another thing which we had looked at yesterday was, okay, that we had, I think we can see it here. Okay, fine. We have in Java, we have got lots of packages. Okay, we have got packages, and the members of package are organized. So all these classes, interfaces, enums, annotations, and records, they are all organized into packages, right? Now accessing or using any of the classes or interfaces or enums or annotation by a class which is defined in the same package can never be restricted. Okay, fine, which is found in the same package, that will never be restricted. Fine. But all those but these classes would not be accessible outside the package unless they are public. Okay, and only public members of a package will be accessible outside the package. So we have for members of a package, we have got two kinds of access specifier. Either we give a public access specifier to make it available everywhere. Everywhere would mean within the module, fine, at least within the module. And we'll discuss module things later, but okay. But as far as the default access specifier is concerned, okay, and when we don't give an access specifier, then it is available only within the package. It won't be available outside the package. Okay, so you might create some classes only for use within the same package. Then fine, don't make it public. Okay, but still the good idea is to have the file name matching the class name. Okay, it's not mandatory when it is not public. Okay, fine. Other thing then we started looking at was if we want to access members of a class, fine. Fine. This is access specifier related to members of a class. So access specifiers for members of a class could be, there are four options, right? You either declare it to be private, in which case the accessibility is not available outside the class, and only within the class. Okay, if we declare a member to be default, we don't declare any access specifier, the accessibility is within the package. We call it as a package level access. Okay, within the same package, any other class, it's able to access it. Right? If we declare it protected, it would be similar to the default. Right? If we declare it as protected, it is similar to default, except for the change that it is getting inherited even by a class which is outside the package. Okay, it is getting inherited. That inherited member is available in the subclass. Okay, but in the subclass, it is available on instances of the subclass only. It is not available on instance of the superclass. Okay, where the superclass is not part of the same package. Okay, and public, yes, public is available within the module, and unless the module is exporting that package in which that public member appears, okay, it won't be available outside the module. Okay, fine. So access specifiers here. Okay, let's now look at the structure of a, maybe a part of the structure of a Java file, right? So if you look at structure of a Java file, and not the whole structure though at this moment. Okay, then a Java file, what does it have? Let's see this. Okay, so a single Java file would initially have it has an optional thing called keyword package followed by package name. Okay, a semicolon. So this is an optional thing. Anytime you use a Java file, the first thing you can do is, this is what you can do first. So you can make a declaration of a prefix for the members being defined in the Java file. Okay, and it's a declarative statement. Okay, fine. Then the next thing which you can do is you can use, okay, let me expand it later. So you can have import declarations. Okay, so any number of import declarations can be there. Packet declaration, only one. Okay, but import declarations can be, and it's optional, so there can be any number of them. So I'm putting 3 dots here. Okay, so fine. This is to indicate, square bracket here are indicating that this part is optional. Okay, and 3 dots is to indicate that we can have any number of them. Okay, so there can be any number of import declarations, and then only our definition for, okay, so this again I can say as far as the Java file is concerned, okay, let me put the 3 dots, and it can have class definition, fine, or it can have interface definition, fine, or it can have enum definition, fine, or annotation definition, or it can also have record definition. Okay, so any number of such things can be there in a Java file. Okay, so yes, you can have multiple class definitions, right? These three dots. So it could be any number of class, interface, enum, annotation, or record appearing in a Java file. Fine. But you wouldn't find more than one if it is a public. Not more than one public member. Any public member will match the file. Okay. So this is a broader structure of the Java file. Yeah, so one thing about, so first thing was, where does packet declaration appear? If it is used right at the beginning. Okay, where does import appear? Before any of these definitions. But if there is a packet declaration, then import has to follow the package, and it can't appear before package. And then only the class definition, all these definitions will come. Okay, fine. Okay, so now for a class definition, yes, what are the, so if I look at the class definition, yeah, how does the class definition appear? It will have optionally a public declaration, fine, followed by the keyword class. Of course, what we also have, which we have not seen, are there are some, oh, we can have, right? We have seen this final modifier, we have seen, right, earlier. So yeah, a class could also optionally be final, and final may be used with class. Okay, and then you give the class name. Okay, what else? What we have seen, following the class name, you can use a extends declaration. Okay, fine, and specify a superclass. Okay, fine, and then we have the body. Okay, so till this moment, what we have studied, from that we know this is the structure. Okay, within the body, what are the things we can have? We can have variable declaration. Fine, we can declare a variable. Okay, fine, or we can declare a, again, this is an optional part, variable or method. Okay, or constructor, or, okay, when I'm saying method and variable, let's assume it includes a static form also. Okay, or it can have block. Okay, so yeah, the block can be static or may not be static. Okay, fine, and this can be any number. Fine, any number of these things can be there. Okay, so coming to a, so one thing what I can do here is, all of these items, okay, let me use a, because for a few common things, okay, let me just say class member. Okay, actually I have missed out on a few more things in this class member. Okay, after the block, what else can be there? Yeah, there are more things. Okay, so I'll say nested type. Okay, I'm not listing each of those types. We have those 5 types, right, for which nested thing can be done, right? So yes, we can have a nested type as well. Okay, so class member is all of those things. Okay, so for a class member, which is 1, 2, 3, okay, blocks not included, class member. Okay, so except for the block. So except for the block, for all of them, okay, there is one, we can have public, or maybe I start with the private, okay, or protected, or public, okay, and then whatever is a member. Okay. Fine. So this is a modifier available for all the members of a class, except for the blocks. We don't give access specifier for a block, because if you look at the whole thing, we will be using other members directly. Okay. You call a constructor by saying new. Fine. You will be uh, accessing the variables, okay, by using dot. You will be accessing the methods by using dot, right, to access the members. But there's no way to say, oh, I want to use that block. Okay. The blocks are something which are getting executed because of another thing. That simple block, which is without any parameter, is getting executed because you are calling a constructor. Okay. The static block is getting executed because the class is being loaded. Okay. Fine. You don't say, I want to just call that a static block. There's no way you can say, I want to call that particular static block. They don't even have a name also. Okay. Fine. See, even blocks can be multiple. You can break your block into multiple places. Okay. A static block may appear more than once. There can be more than one static block. That is the whole idea. Okay. Fine. So these members are applicable to everything other than block. Any member of a class, okay, including the fine. And then of course, if I look at a, so this is there. So now let's look at a variable declaration. So if it's a variable declaration, for variable, the static can be there. Oh, even static is something which can appear as a modifier for all members except for the block thing. Fine. Block we understand is static and non-static. Okay. Fine. Static can appear. What else can appear? Fine. So final is there except for which members from the above list? Class members for which final can be used. Okay. I think I'll list final separately. Okay. Okay. Let's write it here. So this is what is applicable to for all members except for block. Okay. The other keyword was we had seen was static. Okay. Except for, okay, consider that whole list now. Block can be static. Okay, static is available for block. Okay, we have a block which is static. There's a non-static block. So this is available for, static is available for all members of a class except for which thing? Okay, except for constructor, any other member can be declared to be static. Okay, so you have a nested class, that is also static. You have a nested interface, that is also static. Okay, all members except for, so all nested type also can have static. What else was the other keyword? Final. Except for constructor and, okay, the other members here, this I have never explained, is we have interfaces, right? Except for constructor, nested interface. Okay, and anyway, since we are talking about, so any interface, right? In the other, out of those types, we have class, interface, enum, annotation, and record. Only class can be final. instead of saying except for, I'll just say for nested class. Where is it available? It's available for nested class, variables, and methods. Not for constructor, okay? And no other member. So this is how the fine, whatever access specifier keywords we have seen. Mark, these are all keywords of the language. Okay. And so we understand what are the where and how in a class it can be applied. Okay, fine. Okay, what is the use of package? It was for declaring a prefix. What is the use of import? So what is the use of input? Let's check this out. Okay, I'll write some piece of code trying to understand what is the use of import. Fine. So you have, let's assume we have a Java file which says I have a package called pkg1, let's say. Okay. And it then says let's have a class definition. So we go for a class. So we want to have, okay, we want to have a class called, okay, new class, let's say. Okay, so we have a class called new class. Okay, in that case we understand it is pkg1 dot new class. What has been defined as pkg1 dot new class. Okay, now in this class definition we understand that anything, all the various classes, they have a full name. Okay, all the various classes, they are going to be available only by the full name. Okay, we haven't used a class, but let me tell you about a class. There is a class very commonly you may find being used. If you look at the various texts in the on the net, you might find a class by the name java.util.scanner. Okay, this is used in order to take input from the keyboard, very commonly used in that manner. Okay. Anyway, there are much more usage of this. So Java util scanner is one of the classes. I'm writing full names only. Okay. So in this class, anywhere I want to use java.util.scanner, I can always be saying java.util.scanner. For example, I'll say java.util.scanner. Okay. sc, my variable name, equals new, and then again write java.util.scanner. Okay, and okay, whatever parameters, I'm not writing the parameters, it's all about how the scanner class has been used. Okay, so this is one way we use a scanner. There's no problem with this. Okay, but each time we are saying scanner, we have to write java.util.scanner. Fine. Instead of writing java.util.scanner in each and every place, I can put import java.util.scanner like this. If I have this import declaration which comes before, so it's like saying in this Java file, so both of these package and import declarations pertain to the entire Java file. Okay, what packet declaration says, anything being defined, we know those 5 things are being defined, anything being defined has this as a prefix. Whereas the import declaration is saying anywhere you come across whatever is the last part in the import, it says scanner. So anywhere in this Java file, if you come across scanner, you need to replace it with this. Okay, so scanner should be replaced with java.util.scanner is what the statement is made by import. Okay. But let's look at what can happen here. Okay, fine. So in this Java file, if you're writing java.util scanner, oh, this is working for me. Now, what exactly happens when someone says, if it comes across scanner, sc1 equals new scanner. Okay, and dot dot dot. Right? There can be something here. Now, if you look at the compiler, what the compiler is doing? Compiler is looking at the word scanner. Okay, when it is compiling the code, it has to scan all the tokens. It finds, okay, there is something called scanner. It doesn't have a prefix. The first thing it will do is, it will assume, or it will try to map, can I have a type called, so it is what is being assumed, find the first thing, right? Okay. It tries to look for it is always going to look for the current package. Do we have pkg1.scanner as a valid class or not? If it is able to find, someone may have said, let me have package pkg1 and defined a class called scanner. Not only class, it could be any of those 5 items, class, interface, enum, annotation, or a record. Right? But pkg1.scanner, I find a class file for this. I can load this. If I can load this, then this scanner is to be replaced with pkg1.scanner. It will be loaded as pkg1.scanner. Okay, so if you are writing scanner, okay, and if it happens that the current package has the same class, okay, fine, the import will not help. This import does not mean anything if the current package contains the scanner class. Scanner, if it is a valid class in pkg1, then an import which ends in a scanner has no meaning. It is ignored. Clear? So because the idea was that, okay, I'll not write the whole thing, I'll just write scanner and it should mean java.util.scanner. No, it won't mean java.util.scanner because I'm able to find pkg1.scanner. pkg1 is my current package. Okay, so you can see that what is a import declaration? Fine, it's a fine. It is giving me a shortcut for fine. It allows me to have a shortcut way for type names of class, interface, enum, or anything. It's just a shortcut. I don't write the full name. I'm declaring a shortcut. Okay. So in this Java file, everywhere you need to do this, but it will not work if what you are trying to find a shortcut for is part of the current package. So first preference is for the current package. Okay. There's another kind of an import. Okay. There is another kind of import. So we do have an import where I can write something like this. I can say java.util.star also. Okay, java.util.star. Now, why I brought this java.util.star here? Okay, maybe what I'm doing here is, let's see how it is working, then we'll realize how the compiler is working. So you might have, there is actually a class called java.util.date. Okay, so someone might be saying java.util.date t1 equals new java.util.date and can create an object of the date class. Okay, this is the normal thing. But because of my declaration here, import java.util.star. Okay. Normally, let's see how the date thing will work. Okay. If I have said date d2 equals new date. Okay. This is the code which has been written. Okay. How the compiler goes about finding out, because this doesn't have a prefix, date doesn't have a prefix. So it's saying, okay, let me see how I should go about looking for it. So what's the first choice for date? What is it looking for first? What's the prefix it will try to map with first? Even before looking at the import declaration, it has to try to match with. So first choice will be, oh, do I find pkg1.date? If pkg1.date has been defined, then this gets substituted as pkg1.date. A date here, right? No import will help. Okay, fine. What's the next choice? The next choice is, okay, date is appearing. Do I have an import declaration, just like similar to what we did for scanner? Do I have an import declaration where the last element is date? Okay, if that is the case, yes, I know how we did for scanners the same way. So if someone was having java dot something or whatever it may be, but something ending with dot date semicolon, that's an import. Oh, whatever was specified earlier, that is what will be used for the substitution. So it's a substitution which is being done for. So it's a fine. Instead of writing the whole name, I'm able to write a smaller thing. Fine. In this case, what would happen is, let's say pkg1 doesn't contain this date class. It doesn't have a date class. I have not declared anything which ends in a date. In that case, let's look at those imports which end in a wildcard. Right? This is ending in a star. So when it is ending in a star, okay, then this is, we call it as a wildcard. Okay. Okay. So this is a import with a wildcard, and that star is a wildcard. So if we have a wildcard, right, what it should do is, okay, I've tested that I don't find in the current package, I've tested there's no import which is ending in date. Let me now substitute for the wildcard. If I substitute here, okay, oh, if I substitute date, the token for which I'm currently trying to map what it is about, right? So I'm looking for date, what is the prefix which is possible. So if I substitute here date, okay, and if it becomes a valid, java.util.date is a valid thing, oh, then this is what would be substitution done, right? So this will get substituted as java.util.date. So first choice, current package. Second choice, fully declared import declaration. Third choice is the wildcard. Okay. Now, let's see what happens in case someone uses another wildcard import here and says, oh, I have the java.sql.star also. There is another wildcard declaration. And the idea here why I have used this particular declaration is because java.util.date is valid, as well as java.sql.date is also a valid class. We have the date class, which is, so we do have something called java.util.date, and there is also a java.sql.date. Both are valid dates. Both are valid type. There are two separate classes, one appearing date class, one is appearing in java.util package. There's also another date class which is in the java.sql package. Fine. So now when the compiler comes across the token called date, so if I have just written date, what will be the substitution? I don't find date in the current package. I don't find an import ending in date. Fine. Then what do I do next? Look at the wildcard. Third choice is go for the wildcard. In the wildcard, I find there is a wildcard java.util.star. Okay, and that makes this date valid because java.util.date is valid. Oh, I find another one java.sql.star. Okay, so that is also making it valid. Java.sql.date is also valid. So what should it do? What should the substitution be? Fine. Then what happens here is this is a compilation error. Compiler says, I can't make out, there is more than one option here. And this makes it ambiguous for the compiler. So this kind of thing. So if we have two wildcards, okay, fine. In that case, so what is the choice for me now? I want to use those two wildcards because maybe there are other things from java.util.star which I am using. What is the choice for me that in this Java file, how will I be able to use java.util.date? So I can do it. One option is always there, which is I'll write the full name. This choice was always there all the time. Okay. Or the other option is to have adding a import declaration. Okay. Adding an import declaration saying java.util.date. Okay. This will prevail over any other wildcard. So before wildcard, this is what will be preferred. Okay. In this Java file, I am interested in using java.util.date and I'm also interested in using java.sql.date. Now, with this kind of a declaration, import declaration, the current way we have, okay, a date, right? This date is no longer ambiguous. Right? The date here is no longer ambiguous, and we have java.util.date is what is the substitution done for. Okay, fine. If I want to use java.sql.date also in the same package, no choice other than writing the full name. Okay, so if you want to use java.sql.date also, fine. You will have to write java.sql.date. You can't use a shortcut. Here, okay. So now let me also tell you about some of the packages which we have in just the names of the packages which are available in the Java library. Right? We have the Java library, Java API we call it as. Right? So in the Java library there are not many packages. Right? One of the commonly used package is the java.lang package. So in java.lang package we have lot of classes. Some of the classes which we have used so far, okay, for example, the class string, we have been using string. The class string, fine, and then even the class called system. We have the class called system. Okay, we have used the system.out.println. These both belong to the java.lang package. We never wrote an import declaration. We didn't say import java.lang.string. We didn't say import java.lang.star also. And we are able to use string and system without a prefix. Till now, we should have been using java.lang.string and java.lang.system. Okay, but what exactly happens is the compiler always assumes in any Java file, and all Java files, they assume, okay, they assume an import like this. They'll say import java.lang.star. So even though not explicitly declared, this is available in all Java files. Or rather than available, I should say assumed. Okay. And that's the reason, yes, we were able to use string. Okay, fine. And I think earlier I had, quite in the initial stages, I had once shown you the demonstration where we said, okay, if we have a Java file, we had something like hello. Fine, I think hello.java was used, right? In that, I had put a class called string, and then we found that compiler wise no problem because compiler is able to resolve. Okay, we didn't have a packet declaration then, so everything was belonging to the same package, which was the unnamed package. Okay, so wherever we use java.lang.string explicitly, that was working properly and for runtime. Okay, and especially so if you were writing public static void main, and we normally write string array, right? No, it's not string array. Basically, it should be. So if in the current package, this happens to be, string class happens to be available, okay? This will be taken as that particular thing. When we run a Java file, okay, what is our Java application? It is, the Java application is a method name, which has as a parameter java.lang.string array, not string array. String could be any from any package. If I just say string, it could be from any package. Right? But we are looking for string from the java.lang package. Okay, so this is one kind of an import which we have seen. Okay, this has three things, right? You can have. So what are the see two imports we have seen? Two forms of import. One with wildcard, other is specific import, right? Very specific. Okay, one thing what is not allowed as a wildcard or something like this, import maybe I have got package and sub package. I'm just assume I'm looking for pkg dot sub pkg star. This is okay. Okay, fine. This is still valid because yes, we can have any number of levels being created in the prefix part. Okay, fine. And but so this is valid. But if someone says import pkg dot star, that's not valid. Okay, fine. Only for the last element, either it's a exact name or it is a wildcard. We can't have two wildcards here. Okay, fine. So this is not valid. Okay, fine. We understand how the substitution is getting done. Okay, so if someone writes, see, I might, okay, let me show you some more classes with examples. Right? We do have a class called, so I'll first give you the names of the classes here, full names. We have java.lang. String that we understand, right? We know java.lang.string, java.lang.system. We have java.lang.reflect dot method. Oh, there is a class like this. Okay, we do have a class like this, and if someone says, oh, I am doing an import java.lang.star, okay, so does this mean that this becomes, can I use a method? Okay, this is, can I use method class in this without specifying the whole name? If I write method, fine, is this import taking care of the subpackage? I'm saying java.lang.star, right? Is this going to take care of anything which is member of a subpackage? Subpackage of java.lang is the reflect. Fine. Java.lang is one package, java.lang.reflect is another package. Java.lang has its own set of members. Java.lang.reflect has its own set of members again. Okay, fine. Import which is like this is a wildcard. It doesn't substitute for the sub package. Okay, it will not substitute for this package. Fine. So method is not going to become valid because of import java.lang.star. Okay, clear? So you only have that element substituting only one thing. With star, yes, it's only one name, not multiple levels. Okay, fine. So clear? Any other questions you feel, oh, could this also be possible? You can ask that. Anything else you would like to try out, maybe? And is the import declaration till this point clear? Hmm? Yeah. Fine. Is there any other? Yeah. But anything you feel, oh, it could be this way. Fine. Anyway, you can ask anytime, even tomorrow also. By tomorrow, if you think, oh, there's something which can be tested this way. I have one question, sir. Yeah. Let us take an example of date class. So basically, we have a date class in Java.util package as well as Java.sql package. Yeah. Suppose in my class, I am using both. I want to use both date objects. Like in one yes. method, I want to use util date. And another place within the same Java file. It's not only within that yes. class itself, within the same Java file. So see, it's yes. like this. If it is coming across date, fine, there will be only a unique substitution. There can't be two different substitutions for the token called date. Okay, so for one of them, what is a better idea is that you will use import, okay, which is being used more often. Is it the java.sql.date which is being used more often, or is it the java.util.date which is being used more often? So let's say it is java.sql.date which is being used more often. I will put import java.sql.date semicolon. Okay, so date gets substituted as java.sql.date, and wherever I want to use java.util.date, I have no choice but to use the full name. Okay, so substitution for date will be java.sql.date. And anyway, for the other one, I'm not taking the help of import. Import was just to help me out to not write the full name. Okay, it's what is happening is the compiler is making the substitution. When the thing is compiled, it is always with the full names. The class file doesn't say a date. The import has no there is no impact of import at runtime. While compiling itself, it has determined what it is. Fine. So when the code is compiled, the class file contains according to the fully qualified name. Okay, so import is not a statement which is an executable statement, it's a declarative statement. Fine, is it clear? Yes. Okay, so fine, so whatever is more often used, yes, you put the import for that, so then you can use it, use the shortcut only for one of them, but not for both of them. Okay. Okay, fine. Now coming to the static things, right? See, if we have static members in a class, how are they used? Class or even in interface, right? How are they accessed? Okay. They are always prefixed with a
last name dot.
I'll just say type name. Okay, I'll just use the word type because it could be even for an interface, right? Interface also may have static members. So, so static members are allowed for whatever type, right? So they are always prefixed by the type name, and that type name can be written as whether the type is fully qualified or not. Okay, that is one aspect. Right? In that case, the import is, we know how to write an import for a class. But what we have is, I think this is from Java 5. Okay, we have what we call as a static import. Okay, so we have a simple imports for the types, but we do have static imports for, okay, members of a type. Okay. When members of a type, it's not for the type, it's for the members of a type. Okay, so we can write, for example, let me show you a simple example. We have been using system.out.println. Everywhere you are using system.out.println, and maybe whatever we are printing, that's fine. Okay, so in our Java file we are writing like this, right? What is out? Right? Out is a static, right? It is a static member of the system class. Okay, that's why it's prefixed with a class name. Okay, of course, what is that system class? It is the java.lang.system class, I should rather say. Okay, so one may write an import. Now another import which I'm showing is like this: import static. Okay, and let me write the fully qualified thing: java dot, oh, sorry, not util, java.lang.system.out. If I make a declaration like this in my Java file, I can just write out.print or out.println. See, when it is coming across the variable out over here, it knows this is a place where we are not talking about a data type, we are talking about a variable. Okay, we are talking about a member. When you are saying .println, oh, class won't have a method, right? Class or interface don't have a method. Their methods are member of a class, right? Class or interface. So when I'm writing out, it knows that from the context, it's able to make out that this is not, out is not about a class name, it's about a member of a class. Okay, so it will see that fine. Fine. So now there's no question of looking at something like a current package, but then it will see, do I have a declaration of an import for a static? Fine, import with a static. Okay, this is what is import static, right? We call it as a static import. So import followed by static, that's the way it has to be written. Okay, and then what is it followed by? See, what is this? This is nothing but fully qualified name for a static member of the system class. Okay, so this is saying the last element here is out. So if you have used out anywhere, yes, it will be substituted like this. Okay, let me also show you some more examples of using static variable. Other thing was, I think we have this class called math. So in java.lang package, Okay, fine. So we have this class called math. And what are the members in a math? Some useful members of a math. Okay, so in the math class, we do have, there is this thing. I think I was mentioning this yesterday. Public static final double and says pi, capitals, okay, equal to, and there is something which shows the value of pi. Okay, so if you, wherever you want to use the value of pi, fine, you can say math dot pi. Right? So when I write math dot pi, what happens? When the compiler comes across math dot pi, oh, math, I assume this must be the name of a type, right? Okay, so here it says, okay, we have java.lang package, java.lang.star is an import, so it is making substitution as java.lang.math.py. Okay, now this is the fully qualified name for a static member called pi. So import static can always have, could always have been used. Okay, so one can use an import static which says import static and okay, import static and the fully qualified name. This is one option. And here also with import static. So import static is not for the type but for the static members. Okay, and not only about variables. In the java.lang package, we don't have just a static variable like this. We even have public and static, again static, so it's only related to the static members. Okay, we do have a method which returns double. Name of the method is sign. Okay, and it takes as parameter a double. Fine, so some input will be there for which the sign can be computed. There'll be some code for this, that's fine. Okay, and something is available. So how do I call the sign method? To call the sign method, I would normally have been using math.sign and then call something, right? So instead of this, I can call sign and this if I have a static import for this. Okay, this is not valid unless this thing, sign of something is not valid unless there is an import. It becomes valid only with the import which says import. What would be the import? java.lang.math.sign. Or like sign, there are so many methods. So someone can also write an, oh sorry, this is not the import, this has to be for the static members. So yeah, static keyword is a must. Okay, because this is not a member of a package, this is member of a class. Okay, static member of a class. So we have to say import static. Okay, you could have an import static which also uses a wildcard. So instead of this, I'm saying star. In which case, I will not be able to use only the sign. I'll also be able to use cos. Okay. Of course, what is being assumed is cos is not matching some other. Cos is not a method in the current package. It's not a method in the current class. Okay, not a method in the current class. Someone could have a method called cos also maybe. Fine. So cos, though there is no import which ends in a cos, yes, but it is valid because of this wildcard. So import, the way we do for types, same way it can be done for static members, because static members also have a unique way of writing. And there is a unique way we call them. Whereas non-static things are done on objects, we can't be having imports for them. Okay, because what is going to be prefixed to them is going to be decided by the on which object you want to call them. Okay, so no kind of import can be done for non-static members. Static members only imports is allowed. Fine. Okay, so clear about the import and clear about the package thing. Okay, so now what is our exercise? The next part, right? The next part is that let's update. Fine. Now, okay, what are the things we have so far? Yeah, we have the rectangle class. We have the cuboid class, which is with inheritance. We have another cuboid. Okay, we have the test rectangle. We have the test cuboid. Okay, and these are the classes which we have. And as an exercise, I had given an exercise for defining the class account, and I think I did it yesterday, right? We had the class account yesterday. Okay, so now it's always a good idea to organize, not keep them in the unnamed package. These are now belonging to the unnamed package. Only yesterday we started putting them into some package. Some of the things we have put in a package. So what are the package we would like to have for each of them? Okay, so here is what I'm putting their names. This should be shapes.rectangle. Fine, we want a shapes.rectangle. Fine, and we want a. So first part will be to finish this, that we organize them in this manner. We will have shapes.inheritance.cuboid. Fine, because the things are related to shapes, I would not like to have. So this, let's call it as shapes.cuboid. This is the one with composition. Okay, and we can have test rectangle. And for this one, let's turn it into a test cuboid. Okay, account, yeah, we have, let's call it as bank.account. Okay, and I think we have the test account as well. Okay, so for test account, yes, we would like to have test account. Okay. So now onwards, anything we are writing, we are organizing them into package, not keeping in the unnamed package. Okay, so let's test out whether we have the things properly done or not, and fine, let's get organized into this fashion. Okay, one more thing before I proceed further. When we have compiled the Java files, the class files got organized into folders according to the package. Okay, they got organized into folders according to the package. Okay, if I go back to what I was doing yesterday, right? Sorry. Right. Let's see what I was doing yesterday. It was okay. I went to the src folder. We look at the directory. We have got in the comp, we have the cuboid.java. Fine, that's in that folder. Account.java is right here. Okay, fine. We have the rectangle.java and test cuboid test rectangle. See, for cuboid.java, I had to create a folder and then put it there, right? We can't have two cuboid.java in the same folder. Okay, so the idea would be that yes, we should have. Okay, now if you recollect one more thing, I think it was the test rectangle which we were compiling. Okay, let's compile. Let me show you the compilation. -d ../1. I'll compile again. I'll compile test rectangle. Okay, did we compile this successfully yesterday? I think it was compiled successfully. Okay, but now It won't. It's unable to find shapes.rectangle. Let's see this. Here, import shapes.rectangle, and that's failing. Import shapes.rectangle is failing, right? But now you look at this. If I say this and I also say rectangle.java, I'm giving both the files together, it's able to compile. Okay, fine. Why? Because we have rectangle.java saying, oh, I'm part of the package shapes. The shapes.rectangle, which we are trying to use in test rectangle, is available in the files which are being compiled at this moment. But when I was compiling like this, only the test rectangle.java, it was still trying to look for shapes.rectangle, a Java file which may contain shapes.rectangle, and for that, what it was doing, okay, this is error. Now let's see the change which I make. I'm creating a folder here. mkdir is a command used for creating a folder. Okay, I'm creating the folder shapes here. Okay, and I am moving. Okay, the rectangle.java to the shapes folder. Okay, fine. Look at the directory. There's no rectangle.java here. Okay, look at the directory of shapes. So in the directory shapes, we can find there is a rectangle.java. Okay, and now if I'm compiling only test rectangle.java, it's not giving me an error. Right? When the compiler is compiling test rectangle, it comes across shapes.rectangle. In this Java file, it is coming across shapes.rectangle. When it is coming across shapes.rectangle, in order to know whether this is correct usage or not, what kind of class is it, it has to load that class also, right? To know, check all the things, right? That's whether the usage of rectangle is done correctly or not. So for that, when it is locating shapes.rectangle, it's being compiled in src. So in your folder, it is looking for the folder called shapes, in which it is looking for rectangle.java. It won't, you have rectangle.java here, but it's not going to look for that. Rectangle.java here would normally be used for the unnamed package, a rectangle in the unnamed package. Okay, so like the way compiler was creating the class, the folders, and putting the organizing the class files according in folders according to their packages, same way when we have our Java files which are defining the classes, right? They should be organized into folders according to the package. So one of the things which we will have to do here is to, okay, let me just check my Java files here. Okay, which Java file is open? We have the test rectangle.java. Okay, this is saying package is test, but is in the current package. So this should also be moved to the test folder. Okay, fine. I must have a folder called test, and that's where the rectangle.java should be. I'm just closing it and reopen from the folder. First I'll move it and then open from the folder. Okay, fine. So thing is, the Java files for all of these will have to be organized in the same manner. Okay, fine. So here we want shapes.rectangle. Oh, that is done, right? Currently shapes.rectangle is fine now. It is in the folder shapes that we have the rectangle.java for it. Okay, what about the cuboid? Let's check the cuboid, what's happening. Oh, we have cuboid.java over here. Okay, Oh, have we made it part of the package? By simply moving cuboid.java into the folder called shapes. Oh, we want it in shapes. So let me create one more folder, shapes backslash. Oh, we want for inheritance to be going into the subfolder of the package. So we must have this folder because that belongs to shapes.inheritance package. Okay. Not only that, let me open the cuboid.java and okay. So do I first move it? Let's move it first. Okay. Move cuboid.java. Okay. Where do I move it? Into okay. I move it into the other folder. Fine. So that file has been moved to the shapes inheritance folder. Right. You can see that. Right? We don't have a cuboid any longer over here. Under shapes cuboid, we will find the cuboid.java. Fine. Okay. There is one cuboid which is in the com folder. Okay, I'm moving that also. Com backslash cuboid.java. It has to be moved to shapes. And we are going to make it as part of package shapes instead of saying part of the package comp. We don't want the package comp, but we want the package shapes for the cuboid which uses composition. Okay, what remains is account.java. Okay, let's make a directory for the package bank. Okay, move account.java to the bank folder. Oh, I think the test account is part of the same file. We'll have to take it out. Okay, it will have to be in a different file altogether. Okay, also make a directory called test and move move both of those files to the fine. So those have been moved to the okay. So test contains this, but yes, of course, what we have to now do is make the packet declarations in each of those files correctly. Okay, so this folder has this normally, except for that hello.java, all other things are in folders now, and they are according to the package that we ultimately want to have. Right? So let's do this. Let's make the corrections now in all the Java files for the package declaration. And also other thing which we have found out, let's use all of that information. Okay, I think yesterday I mentioned about variables should normally be public, private, right? Methods normally public, constructor initial in our initial days, yes, we can keep them public. Okay, methods public and variables private. And what about the classes themselves? We'll make them public. Okay, so let's make the changes which are needed. So under the src we have the okay, let's start with the shapes thing. This folder is, I think, currently empty. That com folder is empty. Okay, rectangle.java is done with, but let's go to the cuboid.java. Okay, this is the one which is using composition, and the package will have to be shapes. Fine, this is what we wanted. What about the class? It should be public. Okay, what about the members? Private. Oh, we haven't done private for the rectangle class also. Yeah, we'll have to do that. What about the method? Sorry, the constructor. So yes, here we are making it public. Okay. And public to make them available outside the package. Okay, so let's save this. Yeah. Okay, so this is what is correct for the cuboid which uses composition. Okay, this is a cuboid with composition. Okay, and let's open the just let's check out with rectangle.java also first, and let's see if we have finished everything correctly or not. So package shapes, and we still have to make the members private. Okay, variables will have to be private. Okay. Static variable, yes, we would like to have it private. Okay, the static method is public. Yeah, I think the methods we had made them public. Blocks do not have an access specifier. Constructors are public, methods are public. Okay, so this is done with. Okay, let's look at the next file. Look at the one which uses inheritance. Okay, package shapes dot inheritance, and that is done. Okay, packet declaration is proper. And what about this? The class will be public, and we have the private members now. Okay, so members private, variables rather. Okay, and constructor we will make them public. And methods again public. Okay, so this is done for the one which uses inheritance, and then so shapes and the subpackage is done with. In SRC, next one, okay, let's pick up the test thing. Test rectangle. Oh, package test is already there. And okay, we can just make the class public. Okay, it has only one member, which is a static method, right? There's nothing else. So yeah, test rectangle is also okay now. Of course, we might get some error messages if we have used something which now we have made private, right? If we have directly used a variable, I think most of that has been commented out, right? We were using count, but now we have started using the get count method, right? Or length and width being used anywhere. Instead of that, we use the get length, get width method. Yeah. Fine. The next thing is test cuboid. Okay, test rectangle done. Test cuboid. Okay, this was made part of the package test. Only thing, class to be made public. Okay. Yeah. Now coming to the okay. And we have the account.java. Okay. Oh, this has to be made part of the bank. Okay. We will have this as a public class. Members private, and variables will be private. Constructor currently public. it's a variable which is private, constructor public, okay. Methods are being made public. Yeah. Okay. Fine. So this is the bank class. Now, oh, here comes the class called test account. Okay. This has to be taken out from here and put into a separate file. Okay. Fine. We want a separate file for this. Let's create a new file to have the, okay, this new file will be saying okay, I've copied it from there. Okay, and class, yes, we want it to be a public class, and we save this file into test, and this will be saved as okay. So this is test account. Yeah. So organizing those files, yes, that's what we have done currently. Only thing to be checked was you might get some compilation errors now. Okay. Yeah. Okay, let's try compiling the files and correct the errors, whatever we are getting. Which one? Let's compile test backslash test rectangle.java. Okay, so test rectangle compiles, test cuboid. Okay, fine. Now this is using rectangle, which is in a different package. We haven't used the import in the one which is, yeah, we don't need an import. Yeah, it's a cuboid also which is creating a problem. Okay, so this is test cuboid. Of course, this test cuboid was using the uh, inheritance cuboid. It's not the cuboid which we had defined for composition, right? This test cuboid was written earlier, meant for the cuboid using inheritance. Okay, so yeah. There is a shapes.cuboid in any case. Okay. Let's check out what are the things we have. This is cuboid.java, part of the package shapes cuboid. Okay. Of course. Now let's come to the see in test rectangle. What have we done in the beginning? We have used an import for the rectangle. And that's why everywhere where we have used rectangle, it's able to know. What about the test cuboid? We've used the cuboid class, okay, and we have used the rectangle class. Now here, which cuboid do we mean? There are two cuboids. Which cuboid do we mean? we'll need the import. Now shapes dot inheritance dot cuboid. See, this was designed for shapes dot inheritance dot cuboid testing at that time, right? So if I put inheritance dot cuboid, okay, and I put the import for shapes dot rectangle, then that should be fine. Okay, fine. We might have some difficulties with the inheritance dot cuboid because that class may be trying to use some of the things from the rectangle class, which is currently now not part of the same package. Okay, so if we are using some private variable, that would turn out as an error. Fine, we'll correct. Let's see. So compiling test cuboid, oh, we're getting more errors now. Yeah. This I think is the earlier errors, right? Oh, now we have it from here. So here now it says cannot find symbol rectangle, right? Oh, we have only written. No, this is in the cuboid class. See, where is this error? We compile test cuboid, but it has to still got to compile shapes inheritance cuboid.java, line number 4. Let's check this. This is which cuboid? Shapes. We have another cuboid that's here. Yeah. Okay. And in this cuboid, yes, the package shapes is there. When it says rectangle, right? See, it's using the word rectangle. Okay. When it comes across rectangle, it will check whether shapes.inheritance has a rectangle class or not and try to use it in that manner. So, but we have it in the shapes package, not shapes.inheritance. Import shapes.rectangle. Okay, and that should solve much of the problem here. Okay, let's see. We will have errors still, but yeah, most of the errors have gone. Now these errors will be related to the access of the private members of the superclass. R1.length, right? Test cuboid says I want to use R1.length. No, we do not normally use variables directly now. We should be using methods. Okay, length is private, and that's an error. See, look at that message also. You can see error. Length has private access in rectangle. So you can't be using it as R1.length. Yeah, R1.length, R2.length, casting and then trying to use them. Okay. Okay, so wherever we are saying length, yes, we would like to use getLength method. This is the test cuboid class. Okay, so don't use variables directly. We normally use getter methods, right? We provide methods to get the thing, right? Okay. Okay, and understand method binding is at runtime. So when we are doing a cast or anything, has no effect. Okay, it's according to the object. Right? This we know. here we've used length here again. Okay, fine. Now this should compile. Fine. So test cuboid compiles, it can run. Okay, it's test.test cuboid now. Okay, so next thing what you can now try to do is, okay, fine. That exercise on account, I don't know, have you now tried, you've been able to get time to try it out on your own? Okay. And so you need to try the things, right? Okay. Right. So let's see the next one is account.java. Yes, we have to save this. Okay. Just going back to the test cuboid. Okay. In the test cuboid, we have been able to test the cuboid which uses inheritance. Now here is a case where in the same class, I would like to use both the cuboid classes, right? And how will I be using them? So for one of them, I have got an import declaration. Fine. For other one, okay, I will have to go for full names. So till this point, yes, let's say till the point which we have here, we have used the other class. Now I am saying shapes dot. So we have no option but to use the fully qualified name. Shapes dot cuboid. We have used what, C1, C2 only, or other variables have been declared? C1, C2. Yeah, we can have C3, C4. C3, C4. Okay. C3 equals new cuboid 7, 5, 4. Okay. System.out.println volume of C3 plus C3 dot volume. And calling the volume method, let's check it out. Okay, and just doing a little bit, that's fine. Just to test out, yes, we can use this test. Oops, sorry. Now to compile test cuboid. New cuboid. What is new cuboid? See the error? In a hurry, yes, we have done the new cuboid. New shapes. Okay, right? C3 type is shapes.cuboid. But if we just say cuboid, it would have meant shapes.inheritance.cuboid. Okay, so can compile and let's run. Okay, so last thing, C3 also it's able to find the volume. Okay, so in the same Java file, right, in the same thing, we have been able to use both the cuboid classes. Okay, clear. One of them will have to be with the fully qualified name. So we said, okay, inheritance has been used more often because that's what it was initially created for this test, right? But then we have been able to use with, okay, Okay, then fine. I think yesterday have I pushed or not? Oh, not this one. Sorry. Okay, I want to take the text file and just add that. Yeah, Tapan, I think I have not added you to the Git. So today I'll send you an invite. Yeah.
Sure.
Okay. So all this source and the text file which I am writing, that is available on is available from Git. It's on gitlab.com that I created this account.
Okay.
Yeah. So yeah, any questions? Yeah. 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 It was more about organizing everything into packages, fine. And we have understood about the access specifiers also. Okay. So any questions so far for any of the topics which we have done so far? Any earlier question from anything earlier? Yeah. Okay, fine. Then we meet tomorrow. Okay. Fine. So yeah. So we'll continue tomorrow. Then. And tomorrow, what we should be looking at? Okay. Fine. I think just if you could wait a minute. Right? Okay. I'll give you the exercise. Okay. Fine. We have the account class. Okay. Now we want to go for subclasses of account. Fine. We would like to have subclass of account called current account and savings account. Okay. Fine. The two subclasses, right? As far as the current savings account is concerned, it will have a subclass which will be this class subclass will inherit everything as it is. Okay, but you still will have to provide the constructor. So you will have constructor with 3 parameters and constructor with 2 parameters, similar to the constructor which is used in account class. Okay, so constructor point of view for savings account and current account, they're just going to use the constructor of superclass. Okay, they just have the similar constructor, that is constructor with 3 parameter and constructor with 2 parameter, and invoking that constructor. Okay, okay, and then as far as the current account is concerned, and in the class current account, we would like to have mechanism. We would like to have the as far as the withdraw method is concerned, we want to override the withdraw method. Okay, and for that purpose, what we do is we have additional information like, okay, every current account is supposed to maintain some minimum balance. Okay, if that current account falls below the minimum balance, okay, then each time he does such a withdrawal where it is going below the minimum balance, we deduct a penalty amount. Okay, additionally, a penalty amount is also to be deducted. Okay, if you have the text, okay, I think I have also shared a textbook, right? The part of the first 12 chapters. Okay, so in that case, you can look at that exercise. What is the exercise defined for chapter 6 or 7? And that's the place where I think I have talked about the subclassing. Okay, the chapter related to subclass. Okay, inheritance. It may be 6 or 7, chapter 6 or 7. 6 probably is on, no, it is 6 is the correct one. Okay? So exercise 6.1, 6.2, whatever. Fine. Okay, fine. And then we can, so try that out. Yeah. Okay, thank you.